Okay, we're looking at arc length in this video, and I want to lead with a question. There it is. I'm hoping intuitively you would go 200 kilometers, and you would be correct. So the distance there, what I really did is I did the 100 kilometers per hour times the 2 hours, and that would be 200 kilometers. So a few things are happening there. The units are working out nicely. The hours sort of cancel. And basically its distance is the speed times the time. Now, that is absolutely true for constant speed, but for variable speed, if I'm like speeding up and slowing down, distance will be the integral of speed with respect to time. And it still works exactly the same and just allows for you to speed up and slow down. Now, this is going to be really relevant for arc length of curves. So we got a curve here, and I would be wondering, what is the actual distance along that curve? Yeah, now I'll just show you the formula. Well, distance is the integral of speed with respect to time. But how do we define speed for a curve like this? It goes from 0 to 3 as well. Speed was the modulus of velocity. And the velocity is x dash of t squared plus y dash of t squared. So if you want to find the speed, what you've got to do is essentially integrate that thing. That's a formula that needs to go on your cheat sheet, and it's written a lot neater than I could write it up there. But that's essentially what you got to do. Okay, so let's get x dash and y dash. So this would be x dash is 3t squared, y dash is 6t. And this is going to be a pretty nasty integral to do. It's a quartic under a square root. No way I want you to do this integral by hand. So we're going to do it on the calculator. One funky thing will happen with integrals sometimes. Since we're still in parametric mode of the graph, sometimes I can mess with it, with whether it uses x or t. So I'm going to get you to just set it back to y equals, just to make sure. Probably doesn't matter, but we just like being cautious here. We're going to go integral. We're going to go for the square root of all that stuff. 3t squared and 6t all squared. And we'll close the brackets, and that should be everything we need. 0 to 3 for the bounds. And there it is, 38.9 essentially. Done. That's how long that thing is. Yeah, are we right? How do we know, first of all? So a good guess. So this would be like a good guess at what that speed is, what the distance is, sorry. So we could use Pythagoras on this. So the triangle, this is -2 up to 25. So the triangle is 27 wide from the start of this curve. And the triangle goes up from 4 to 31. So conveniently, that's actually 27 high as well. That's just a coincidence. So our guess would be the square root of 27 and 27. And if we guess that, we'll see what we get. 27 squared would give us 38.18. So this would be sort of a underestimate. And then this would be sort of the true value. Now I'd encourage you to think about why that green line is an underestimate. Pause the video if you want some time to think. But it's because the red line sort of doesn't take the shortest distance. So not only is this an underestimate, but it's also the shortest distance between those 2 points. And then the red curve sort of takes a windy path. So as I'm sure you can imagine, we could have all sorts of crazy wild paths to get from there to there. But the green path, which is a straight line, would be the shortest one. Okay, find the circumference of the unit circle. So we better model the unit circle using an equation. So x of t is cos of t sine of t. We'll do just fine. Now this will be 0 to t to 2 pi. That's how we define the unit circle there. And this comes from trig parameterization. So the length or the circumference is the distance around the unit circle. So that'll be from 0 to 2 pi of x dash of t squared plus y dash of t squared to t. So that'll be 0 to 2 pi of x dash of t is minus sine t. Square that. And y dash of t is cos t, and we have to square that. And that's going to give us the integral from 0 to 2 pi of root sine squared t plus cos squared t. One of our favorite identities, the thing under the square root there equals 1. We're trying to integrate 1, and the integral of 1 is t. Okay, so you're going to sub in 2 pi to the t value and then sub in 0, so you get 2 pi units. And that is the circumference of the unit circle, because the normal circumference formula is 2 pi r, and the unit circle has r equals 1. So we're very happy about doing that. And that is the end of Year 12 spec.